So if you could please describe to us just your job title and the responsibilities that you take on.
Okay. Well, I'm the little bit of history. Our company, we're about half architecture and half civil engineering, and so I manage the architectural half, so I'm the operations officer for the architectural. And so really that just I provide oversight to the business side of the business, if you will. And so I have a number of people who, we call them sector directors, but they specialize in certain areas of practice like K through 12 school, higher ed, healthcare, and so they report to me, but again, more from the business perspective.
All right.
Okay. How long have you been an architect?
Let's see. 35 years.
Okay. How long?
Had to do the math there for a second.
Have all those years been with Park Hill, Smith & Cooper?
30 of them have been. Mm-hmm.
Okay. What projects have you been working on?
Well, recently I don't get involved much on the project level just because it's more administrative, if you will. But I have been involved. You're probably familiar with the new Buddy Holly Hall of Performing Arts and Sciences. So we're the architect of record or the prime architect on that project, and so I have been involved in that at a higher level. I don't get down into the nuts and bolts, but anyway, have been involved. So.
Okay. What's the most difficult part of your job on a day-to-day basis?
On day-to-day, just dealing with. I mean, it's just part of the job, just dealing with issues. You know, sometimes they are situations on projects where we have a mistake and we've got to figure out how to fix it. And it's, you know, I'm the problem solver. I'm the one that gets when other people can't figure it out, I get it. So I get all those issues and things that have to be worked through. So.
Okay.
What would you say, like, what projects are you most proud of, or in your mind, like, really stand out to you?
You know, over the years, as far as ones I've been involved with, some of the some school projects that I've been part of, and probably early in my career, I did a fair amount of healthcare work for. At that time, it was Methodist Hospital. Now it's Covenant here in Lubbock. Okay. But some projects that we did out there with the Children's Hospital, and a couple of medical office buildings.
Okay. So, as an architect, how do you design the floor layouts, accommodations to best fit like human traffic or foot traffic?
Yeah. You know, you kind of start with the program. I mean, you have to understand what's in the building or going in the building, and then you have to look at, you know, as far as just circulation within the building. You know, the relationships of this department or this area to another, and again, trying to guesstimate. Sometimes it's a guess, sometimes you can estimate it, but you know, how many people are going to be traveling from point A to point B, and is there one way to get there or two or three? And
right.
So some of it's just from experience, but the building codes direct some of that. But usually the building codes are, they're the minimum standards, the minimum requirements, and usually we provide more than the minimum because while the minimum will work, that probably won't meet people's expectations.
Right.
Okay. When you have to remodel buildings with a high concentration of people in hallways or small spaces, how do you modify the existing layouts to alleviate some of that congestion?
Yeah, well, you know, if it's a space issue, obviously you can either reconfigure spaces to make them appropriate for what's happening within that space. You know, maybe it started out as, well, we're going to have 2 people in here, and that department or that area grew to 5 or 6, and so, you know, obviously you've got more people than you planned initially, and so you can expand that area in order to accommodate more folks. But yeah, it's a space planning thing, and but you know, you might plan for this, and then if something changes, you've got to adjust or adapt. Yeah.
So does that just mean, like, sometimes expanding hallways or adding new routes, or what might that look like?
Well, it could be all of those and a few more things. It depends what's creating the issue, what's creating or causing the problem. Is it again? Is it the number of people? Is it the size? The width? Is it at certain times of the day? I'm trying to find that balance, but there's again, depending on the specific problem, there's probably a couple of ways to address it. One may cost more than another, but it's at the end of the day, a lot of times it comes down to money. That's what makes the decision.
Okay. Do you use escalators or moving sidewalks as a way to alleviate congestion?
I mean, you certainly can. I've never had a project where that was a mode of transportation that we used within a building, but you see them in escalators. I mean, you see it in a lot of retail spaces. You see it in transportation centers, in subways and things, airports, moving sidewalks. Typically you'll see those in an airport or something, and that's. I mean, it can move more people quicker, but it can also. It's you don't have to walk, right? You can ride. So there's that part of it too.
Do you think that's a plausible solution for a school?
I think it could be. Again, I think it comes down to dollars, and they're gonna the dollars. They'll say, well, students have feet and legs; they can walk, right? I mean, that's not the answer to everything for sure. But
right.
In the school, that's probably not a
very good
answer.
So at our school, we think that when we have two kind of main buildings where classes are, and right now there's only one hallway that connects the two. So we want to add another hallway or a structure that connects the two. So how would we go about deciding the best location to add that hallway, that connects it?
Yeah. Well, I think you want to know where the people are and where they're trying to go. So, obviously the shortest path would be the quickest, but that may not accommodate existing rooms, or things that you might have to interrupt in order to make that happen. But I mean that'd be where you'd probably start. You'd look at those rooms that are less critical than others that could be made smaller to accommodate a new hallway, because just knowing a little bit about Monterey, and most schools, classrooms are on the perimeter and then the hallways are in the middle. So if you're coming from one building to another, you're probably going to have to interrupt a couple of rooms on the outside walls, and they're probably classrooms or labs maybe.
But then, the design process of drawing the layout of a building, how do you kind of determine the heaviest foot traffic areas?
Again, you kind of look at the spaces and what they're being used for, and part of that's knowing the schedule. I mean, if you've got a gym and there could be 800 people in there and they're all going to leave at the same time, well, the corridors that serve that gym are probably going to be a lot wider, and then they'll get a little bit. There'll be less of them, or they'll get smaller as they get to other parts of the building. But it's really, and I mentioned the building codes. They have a very prescriptive formula that you determine occupant load within a room based on so many square feet per person, and so you can determine occupant load. And then they have another formula that you determine exit width based on the occupant load. There's factors that they give you for different, whether it's a school or a hospital or different types of occupancy, and there's factors they give you that you can calculate the width. But what I found, that's a minimum. And on a high school, in Monterey, you've got some probably 12, 14 foot wide corridors, and my guess is when you did the calculation by the code would say all you need was a 7 or 8 foot corridor. So right now they're probably wider than what the building code requires, but it's done for the fact of ease and convenience and ability for people to move quickly. So.
Okay. How do you prevent choke points or bottlenecking from happening? with like moving people?
Yeah, I mean that's just that point comes from that planning perspective and knowing how many people you're moving, and being aware of that so that you don't create a choke point or a bottleneck.
Okay.
So, how many phases, if you draw an architect plan for a building, like how many different phases or people must that plan pass through before it's to the final design?
There's typically 3 phases that, well, I'll say 4. There's programming, and that's really that's an exercise where you're determining, what type of spaces need to be in the building, how many people are going to be in each space, which would determine how large that space would be, so that you know what you're putting in the building. So that's the programming effort. Then we have what we call schematic design, and that's where you take that program information and you literally start to lay things out on paper to see how, if this space needs to be adjacent or close to this, or if you want them separated because of acoustical issues or whatever. And so that schematic design, you start to lay those spaces out to scale so that they're appropriately scaled and so forth. And then you begin to think about the different systems in the building, the electrical system, mechanical systems, if it's a multi-floor building, vertical circulation where you put stairs and elevators. And so from that schematic design, then we go into what we call design development. And so at schematic, you should have your footprint worked out. And then design development, then you just keep developing that plan further with more details. You start to show lighting, electrical, switching, begin to talk about finishes within those spaces. Structural has been involved, and so you're starting to integrate that into the process. And then the 3rd phase is what we call construction documents, or contract documents. And so that's the final documents that show all the details that then the contractors can use to bid and price and then ultimately use to build the building with.
Who knows?
So those are the 3 or 4 really phases.
How much would you say that the design shifts from the initial draw up phase, or what you said, the programming phase, to the contract phase? Are they relatively? Do they look the same, or
they usually do? That things looking totally different. You get that worked out in that schematic design phase,
right?
Because as you develop the documents more, you don't want to go back. You don't have to go back, step backwards, and redo a lot of things. So you really work out that in that schematic phase. And you may have 3 or 4 wildly different options, but by the time you finish that schematic phase, you really need to be down to one option that everybody says, yep, this is what we want. Yep, that's right.
How often is an architect called in to help redesign or improve an existing building?
It happens fairly often. I mean, things change. Sometimes maybe it's a drastic change. The building was used for a retail store, and now a church wants to go in it. So, they're repurposing or reusing that building, and so it's got a whole different use the second time than it had the first time, and so significant redesign or even within a building that's the same occupancy that it was to start with, a school, and 20 years later it's still a school, but the way education is delivered now, for example, is different than it was 20 years ago, and so there's things you need today that you didn't need, and things that you had 20 years ago that are obsolete, right?
So I guess building on top of that, Monterey was built in, I think, the 1950s?
Around there.
1940s, 1950s.
Late 50s is when they finished it.
So how would you say, are there any parts of Monterey that you think that are out of date, or that if it was to be redesigned today, not really redesigned, but that there's needs in today's school setting that were not present back then? Are there any major aspects you could see that are missing that would have been included in today's world?
Yeah, well, I think probably the biggest thing is just the integration of technology. I mean, everything works off electricity today, right?
Right.
And while certainly there's electricity in '58, but there weren't computers, there weren't phones and all that had to be plugged in, and there wasn't data wiring to connect printers to computers and so forth. And so that infrastructure is totally missing. I mean, they've added it over the years, but from when it was built in '58, that wasn't even on the radar. You know, so you have elements like that were never thought about or planned for that we would need in the future. A classroom is a classroom. I mean, they did put chalkboards in there now. Now you use dry erase boards, right? I mean, but for all purposes, it's the same thing. But as designers, a lot more attention is paid toward acoustics, so the students can hear the instruction that's taking place. And today we're seeing different ways, and everybody learns different. Some people are more visual, some are more, I gotta read it in a book, and so we see schools more flexible and adaptive to accommodate different learning styles that different students have. And some students do better in a small group, some in a classroom setting, and so the buildings that were built 60 years ago aren't as accommodating, as flexible as what we try to do today.
Okay. So kind of going back to that bottlenecking, whenever like someone comes up to you with a problem and you see bottlenecking in it, how do you fix how would you fix the layout to get rid of the bottleneck?
Yeah. Well, I mean, a couple of things you look at, and there's not a one size fits all, but you get rid of the bottleneck, right? That'd be one way. Maybe you create additional routes so that you're not trying to force as many people through that bottleneck, and give them other options, different pathways to go. That could be another option to help relieve the problem.
Okay.
How often does Parkhill Smith & Cooper work with other architectural firms and cohesion in one project?
We do some collaboration, not a lot, maybe probably less than 5% of the time. I mean, generally we're the prime architect and we have that project by ourselves, but we do collaborate on a few here and there.
So I guess would those projects be the really big ones or smaller ones, or?
Usually the bigger ones, because the smaller ones they're too small for more than one. Yeah, it's just but or it may be a case where it takes a real expertise or specialty that's part of the overall project, and so we'll consult or use a consulting architect to help us with this one aspect of the project. It's maybe something that we don't have knowledge or experience with, so we'll go find somebody that does, and that's part of the project, and then we do the rest of it.
Okay. I don't know if this is up your alley or more interior design, but do you know if there's special flooring patterns that help kind of keep people on one side of the hallway or corridor?
Intuitively, I think you can probably do things with, if you're, it's completely visual, but if you've got a floor pattern that is more linear with the direction of traffic flow, that may give reasons to people to kind of follow a line and stay lined up, whereas if it was a pattern that was totally random or perpendicular to the flow of traffic, there would be less to, and I think it's subliminal, but if you have a pattern on the floor that's more, like I say, in the line of traffic flow, you tend to, subliminally you walk down the one path or another. So I think that could influence traffic flow.
Okay.
How long does the average project take from drawing up the plans to actually getting it built?
Well, average is hard,
right.
But if you talk about let's just a new elementary school, it may take 6 to 9 months to design and 18 to 24 months to construct. So you could look at 3 years from when you said, that's what we're going to do to when you move in.
Right. Okay.
So if you had to take a guess at how long a 150-foot hallway extension onto the second floor of Monterey, roughly, how long do you think that would take from start to finish?
To design it and to build it?
Yes.
It's elevated or grade?
Yes.
Or
It
it'd
will.
be built on top of an
Yeah.
existing like hallway. So like I'm trying to like, so at Monterey we have like,
There's your marker. You can draw on that wall. Show me your drawing skills, your sketching skills.
we have the main square part of Monterey that was
Oop,
built
maybe.
a long time ago.
That one's dead. I need to throw that one away.
So main square part of Monterey built a long time ago. And we can have that kind of long annex portion. And then we have a cafeteria like that. And then there's kind of a hallway that connects like this. And then no one really goes to this like hallway just because it's like out, like it's really out of the way. So we have one kind of long hallway that goes from, it's about like right here, right?
Yeah.
It's kind of, it just goes like that.
Yeah.
And then like right now, like these points and then these points, they're both like, you'll spend like 30 seconds just trying to like get through the like wave of people. And it's like, it's not always just like, it's so congested, it's like people stop walking, they're wasting time. So we were wanting to just build another one, like, because both these buildings are 2 stories, and just
Okay.
build one on top of it.
Okay. Because you got people from upstairs that have to come downstairs,
down
and
go
then
over,
walk.
and then go back up.
You're right. So, and then that also makes all the stairwell, like there's a stairwell on each like corner,
Uh-huh.
and that makes these points really bad just because, if you're at the top floor, like you say, to go all the way down, walk across and go all the way back up. So it'd be not like, it'd relieve congestion at like this stairwell and then this stairwell if you could just walk straight across.
Yeah.
So we think that
And there is like an outdoor walkway about like right there in it.
At the
But
second level.
Yeah, at the first level. But that also, like, it's a really crowded area. And then like
And
the
then, like-
stairwell, that bottom left stairwell gets real crowded. And there's a stairwell like right beside it that's
And then,
like probably
like,
one of the worst points.
part of the thing with LASD is, we're trying to cut down, they've passed a lot of grants to improve the safety. And so right now, like this part, it's completely open, so any stranger could just walk right in here and like go through this outside kind of walkway and they walk into the school.
I see.
And they can't, right now they can't really close the doors because then the congestion would be terrible. So we're also hoping that if we added another hallway like right here, then they could close these doors. And then like that helped with safety.
Right.
So, I mean,
But yeah, so it probably wouldn't be a problem to build over it. You may have to suspend over it. May not be able to build on top of it because it probably wasn't designed to carry a second floor.
Right.
That existing connector, so you could build one over it. And that's not a huge project. It might take 2 or 3 months to design and 9 to 12 months to build.
would you say, how would we go about like figuring out if like this pre-existing hallway could carry a load on top of it? Or if like there's any modification, we could like increase the strength or?
Yeah. If you had the original drawings,
Okay.
you could reverse engineer it, see how it was engineered and see what additional capacity it might have. Just as a rule of thumb, unless someone was just planning on doing it from day one, it was in the original plan to build a second floor, there's probably not enough capacity. And so it might be easier just to put a new structural system, just go outside either wall and with your new columns and kind of bridge over it. So your second floor connector is independent of the one below.
Would you say it'd be maybe more cost efficient to, like you said, kind of build a new structural system over the existing building, or do kind of a suspension like bridge type design across like about like right here?
Yeah. Well, I think you could, anywhere in there, I don't think the cost would be any different where you located it within that courtyard. But, if you can go down and provide supports, over the length of the span, that's going to be more economical than if you have to, like a bridge crossing a river and your supports and your abutments and embankments have to be outside and you have to suspend over, so.
Yeah. So we were just hoping that like we like this option better, but we were assuming that because there's nothing already built there, that would just be more costly, and for a school option it'd be best, whatever's cheaper.
Yeah. It'd probably be easier to stay away from the other one.
Stay away.
Mm-hmm. So you're not fighting with working around things that are already there, because you're really not going to get, I don't think you'll get any benefit from that existing connector. from a structural perspective. So then you're trying to build over it and around it, and that's more costly than having a clear area and just boom, here we go.
Okay.
That's it.
Yeah.
Can't think
Is
of
that
anything
it?
else.
No, yes, sir.
That's all? Okay.
Yeah.
I can handle that.
All right, thank you.
So what are you going to do with all this information?
Hopefully,
Hopefully not change our idea again.
because we know a group, they kind of the same, like 3 years ago, they had like
Yeah.
the same idea as us, but they wanted to do like a suspension bridge, and that ended up, like to cut costs, they made it like completely, it was just a concrete slab going across, and it was completely exposed to the elements. So we were hoping that maybe we could build on top of the other one, because we just assumed that'd be more cost effective.
Because the one they designed came out at like 1.5 million, and that was their cheapest
Right.
idea.
Yeah, I really think, because, like I say, unless that existing one was planned for a second floor,
It'd probably
it
be
just
best.
doesn't have enough capacity to add another floor on top
Right.
of it. And so then you have to span over it,
And
work around
typically-
it, and that just becomes more complicated. And you got point A to point B, and you can get them connected.
Yeah, and
You
there's
got-
nothing you just work
Put
around.
new foundations below it or whatever you need.
Typically, y'all won't design for an additional building on top if
Because it costs more money up front, and owners don't want to shell out the money for something that may or may not happen in the future. Usually what happens.
Right.
Yeah, like I say, it sounds like everything revolves around money, and not always, but a lot of times it does.
For businesses, yeah.
That's typically what happens. You know, let's say just know, yeah, in 2 years we're going to put a second floor on that. Then you'll spend the money up front to get the structure in there to accommodate that. But if you do that and then you never build that second floor, well, you spent more money initially than you could have had to. So
Okay.
that's the what you have to weigh.
Right.
All right. Well, thank you for your
Okay.
time.
You bet.
Appreciate you. Thank you.
All right, well, hopefully that's helpful.